what is the difference between sulfide of group 2 and sulfide of group 4? But generally speaking, sulfides are black in color. No discussion is complete without solving the questions. Hello everyone, my name is Sahaj and welcome to ATP STEM. So today we will be discussing about cation analysis. In cation analysis, there are many different kinds of ways we analyze the cations, but today we will be discussing about the precipitation type of analysis. What is precipitation type of analysis and what to add to get a particular precipitate? That is the discussion we will be having today. What are the topics we will be discussing? I told you we will be discussing about the cation analysis through precipitation. We will be discussing about how to make original solution. Now, what is this original solution? We will talk about it and what group reagents we will be adding and accordingly what precipitates we are getting. Let's check. So, what is original solution? So, the analysis which we are going to do, which I am saying precipitation analysis, this is a wet form of analysis. What is the meaning of wet analysis? The analysis we are doing today, it will be analysis in solutions, hence the term wet form of analysis. On the other hand, if you remember, you have carried out flame tests and everything, that is dry analysis. There you don't add any water or make any solution for the analysis. How to make original solution? Let's start. So we have generally the salt given is white in color. So we add that in water. If it is dissolving, okay, that is our original solution and we will move on with that. Otherwise, we will heat it. If it is still not getting dissolved, we will add some drops of dilute HCl. We will stir it. If it is getting dissolved, original solution, move on with that. Otherwise, heat it. Similarly, still not getting dissolved, add concentrated HCl, heat it, not getting dissolved, move to dilute HNO3, nitric acid, still not getting dissolved, add aqua regia, which is nothing but concentrated HCl, concentrated HNO3 in 3:1 ratio. If all these steps you have carried on and still the salt is not getting dissolved, it simply means the salt is insoluble and that is not the discussion we will be having in today's class, right? Okay, so let's start. So based on the different group reagent or different compounds we add to carry out the precipitation, we have segregated all the cations we have into multiple groups. Now these groups, don't get confused here, these groups have no relation to the groups in periodic table. Let's start. Group 0, let's check what all cations we have here. So in group 0, we have ammonium. Why it is called group 0? Because ammonium salts, they don't form precipitate. If they are not forming precipitate, there is no point studying these ammonium salts in this section, the precipitation section. Yeah, okay. Group 1, we have Ag plus and Pb2 plus. Group 2, oh, Pb2 plus reappears here. We will see why. Copper 2 plus, arsenic 3 plus, Hg2 plus, mercuric ion. After that, we have aluminium 3 plus, iron 3 plus, we have Zn2 plus, Mn2 plus, manganese ion. Then we have group 2 of periodic table, alkali earth metals. So calcium, barium, strontium, magnesium is in group 6. Why magnesium is in group 6? We carry out independent analysis for that. Let's check. Okay, so how they are precipitated, in what form we are precipitating them. Let's check. So group 1, they are to be precipitated as their chlorides. Group 2, they are to be precipitated as their respective sulfides. Group 3 as their hydroxides. Group 4 again as sulfides. Now, what is the difference between sulfide of group 2 and sulfide of group 4? We will be having that discussion. Group 5, that is calcium 2 plus, barium 2 plus and strontium 2 plus, we will be precipitating that as carbonate. Magnesium 2 plus, I told you we have separate analysis for that. So that will be discussed later. Let's start with group 1. Group 0 won't be forming precipitate, so we will leave that. Group 1, Ag plus and Pb2 plus. We have to precipitate this as its chloride. So we need a source of chloride. What is the source of chloride? We will add dilute HCl, that will give us ready ions of Cl minus. So that will combine with Ag plus and Pb2 plus and it will be giving us their respective precipitate AgCl and PbCl2. Both of them are white precipitates. Let's start. Then we need source of sulfide. The source of sulfide we have is H2S. We add that in acidic medium. Let's check H2S in acidic medium. Pb2 plus, copper, arsenic 3 plus, Hg2 plus, all of them precipitates as their respective sulfides. Okay, so all sulfides, generally speaking, there are some exceptions, but generally speaking, sulfides are black in color. So the salts we get here, they are black precipitates. Aluminium 3 plus and Fe3 plus, we add NH4OH as the source of hydroxide, source of OH minus, such that they form, OH minus forms bonds with Al3 plus and Fe3 plus to form the respective precipitates AlOH whole thrice and FeOH whole thrice. AlOH whole thrice, it's a gelatinous, I'll just add here, it's a gelatinous white precipitate. And you carry on with this in blue lake test. Fe3 plus generally reddish brown precipitate, and it will get precipitated. Why we are adding NH4Cl? What is the use of that? The usage of NH4Cl, I hope you remember, you have studied this in ionic equilibrium. NH4OH and NH4Cl, they form a buffer. So now, why NH4Cl is added? To control the pH. And you will see, whenever NH4OH is used here in the analysis, it is used along with NH4Cl because we want to control the pH. Remember, buffer solutions were the solutions which upon addition of small quantities of acids or small quantities of bases, they don't, the pH don't change much. So they tend to resist the change of pH. So that is the precise idea why we are using NH4Cl as well. These small points, just keep on writing them because these points are asked in Viva, they are asked as 1 markers here and there in the exams. Okay, anyway, group 4, now we're moving on to group 4, we have Zn2 plus and Mn2 plus, again to be precipitated as their sulfide. So what is the difference between group 2 and group 4? We will have that discussion. The source of sulfide is H2S, and along, if you see, the medium has changed. This is basic medium. On the other hand, in group 2, the medium was acidic. That is the difference. How does it affect the pH? How pH affects the precipitation of these ions? H2S breaks down, though it's a sequential breakage, but I'll just put it in a single reaction. Actually, we need sulfide ions, right? Remember the concepts of equilibrium. If you are carrying out this dissociation reaction in acidic medium where already some H plus are present, if already some H plus are present, the sulfide ion you will be getting won't be much. Why? Because it will form a common ion with HCl, yeah? So if already H plus is present, the amount of forward reaction is not much. If the amount of forward reaction is not much, the amount of sulfide you are getting is not much. But still, in that medium as well, group 2 salts are getting precipitated. Why? Because the amount required by them for sulfide, the amount of sulfide required by them is not much. Why? Because their Ksp value is very low. So if Ksp value is very low, they tend to form precipitate with very less amount of sulfide as well. On the other hand, ZNS and MNS, they have higher Ksp value as compared to group 2. So if they have higher Ksp value, the amount of sulfide required to form the precipitate will be less. Oh, my bad. The amount of sulfide required because of their higher Ksp value, the amount of sulfide required will be high. Now, how can you get this lots of sulfide which you require in group 4? If you carry out the reaction in basic medium. Now, basic medium will kill all H plus, it will take all the H plus, and the amount of sulfide you will be getting in this case will be higher. And because the amount of sulfide which you are getting in this case is high, that high amount is required in group 4. Moving on to group 5. Group 5 are to be precipitated as their respective carbonates. Carbonates are white in color of these cations. Calcium 2 plus, barium 2 plus, Sr2 plus, their carbonates. white in color. For that we need ammonium carbonate that will give us a ready source of the carbonate ions. What colors I have written here? These colors are not for wet analysis. These are colors of dry analysis of calcium 2+, barium 2+, and Sr 2+. These are colors of flame test. Yeah? Okay. In the previous group, I told you while we were discussing group 2 that all sulfides tend to be black in color except for Zn2+ and Mn2+. Their sulfides are white and buff in color. So ZnS is white and MnS is buff. On the other hand, in group 2, sulfides are black in color. So yeah, this is the analysis we have of cations in our syllabus. So now we have a flowchart of all the wet analysis we have. So we started with our original solution. Group 1, we added dilute HCl. We had AgCl or PbCl2 as precipitate. If we are not getting any precipitate, we'll move to group 2. We will pass H2S gas in that HCl medium if we are getting precipitate group 2. Otherwise, we will move on and we will keep on doing this. This is called a sequential analysis. Why it is called a sequential analysis? Because if there is a failure in a particular test, with the same solution we keep on adding the group reagent, right? Okay, so this was all the discussion we had to do with respect to precipitation analysis. Again, no discussion is complete without solving the question. So let's solve 1 or 2 questions here. Let's just hang off the concept which we have just discussed. Start with question number 8 and question number 9 once. Answer in the comment box and we'll start the discussion in 1 minute. Pause the video and let's start. Okay, I hope you have solved the questions. Let's start. Treatment with ammonical H2S. Now, H2S appeared twice in the group analysis. It was present in group 2. It was present in group 4. Group 2 was acidified H2S and group 4 that was ammonical H2S. So this is analysis of group 4 we are doing here. Fe3+ is group 3, Al3+ group 3, Hg2+, Mg2+, that's group 6, Zn2+, that should be our answer. Fe3+ was group 3, Al3+ group 3, Hg2+ group, Mg2+, my bad, was for group 6, and towards the end we have Zn2+, that is group 4 cation, that will give us our answer. Next one, on passing of H2S gas, some cations are given to us. Let's check the group reagent given. The group reagent which is given here is acidified aqueous solution we have, and we are passing H2S gas. So group reagent, this is group reagent for group 2. So all the cations we have for group 2 will get precipitated by H2S passed in acidified medium. Group 2 anions, if we collect copper 2+, yes, Ag2+, yes, Mn2+, group 4, no, nickel 2+, not in any group, gone. So the answer will be copper sulfide and HGS. So we will conclude our discussion for this video. In next video, we will be starting with organic analysis through different tests, and these 3 tests we will be taking in next video. So these will be iodoform, tolerance and fillings. These are 3 important and frequently asked tests from aldehyde ketones and carboxylic acids. So let's deal that in next video. Thank you everyone. Bye bye.